Продолжаем программу конференции.
Welcome back, everyone. We continue our journey into the world of AI. Happy to see you back in the main hall of AIJ 2024. The next block is opened by a discussion on practical AGI. Our speakers are Maxim Yeremenko, the Vice President Director of AI and Machine Learning Department of SPARE, and he will talk about the future of AI and specifically the future of practical AGI and the role of AI research to achieve it. Please give a warm round of applause to Maxim Yeremenko, Vice President Director of AI and Machine Learning Department of SPARE.
Practical AGI.
Рад приветствовать всех участников конференции AIJ.
I'm happy to see all of you, dear participants of AI Journey 2024. This is the last module of presentations in the science track, and today I would like to talk about the topic which I think 5 years ago sounded like science fiction of sorts, but today it is something that attracts investment from all the major big tech companies. I think this is very much relevant to our day-to-day life. Of course, I'm talking about AGI. Some say strong AGI, but we prefer the term AGI. Let's start with a poll. What do you think when the AGI will appear? To decide how to vote, let's agree that we mean by this something that can efficiently make decisions in a similar fashion to high-skilled, high-qualified experts, operate in different modalities, text, voice, all sorts of things, and it doesn't necessarily need to be embodied. So it's not necessarily a robot. We are talking about the cognitive abilities. So let's see what you decide. Please show the results of the survey. We'll see what the audience think when we will finally achieve AGI. Well, I see that the vast majority believe that we are looking at the horizon of 2 to 5 years. Very much in line with the forecasts. Well, let's give it a minute, or rather 10 seconds. And then we can move on to the alternative image, which essentially confirms the majority opinion of the audience. You see these esteemed people. One of them is the godfather of AI, Geoffrey Hinton, and the CEOs of the biggest tech companies. They all agree that if not 1 or 2 years, but at least at most 5 years is when we can see AGI. To move on from this nice picture about futurology and vision of the future to something more close to home, more practical, I would like to describe how we at SPARE have defined this framework that we are calling practical AGI. Why we've done it at all? We've done it to add some structure into what we do in-house and what we do with our partners, with research teams. And more importantly, if you know about the SpaceX achievements, you probably know that over the past 8 years, the company has been developing the launches of this module that can be retrieved, and she's doing it to go to Mars, to colonize it successfully, and to go back if needed. They've had a lot of failures, a lot of falls, and with each fall, They learned their lessons and organized this process, which at every step of the way in technological development allowed them to do some practically useful spin-off of their technology. They continued improving their technology and practicing with the launches. This is a great approach in the modern context that is changing all the time. It says a moonshot here, but for them the more ambitious goal is probably Mars shot. So in our case, we can start with a moonshot, because with AGI we haven't been to the moon yet. Speaking of where we are, in terms of the ability to hack ourselves and our skills, there are 3 or 4 modalities, 3 or 4 emotions that artificial intelligence can reproduce pretty well. Text, obviously. Voice, in one way or another. We often communicate with IVRs by voice, sometimes not very friendly ones. Some of them suggest that we transfer money to some super secure account, wink wink. We often see generated images and we struggle to figure out if it's generated by AI or if it's real. Video is a separate modality, it's slightly different. It is at the level where we can pretty safely say, in most cases, that this video was created by AI. It's pretty evident, and a lot of industry-specific applications, I'm talking about 3D generation and industrial designs, and last but not least, some very moderate and tentative experiments with sensory information. Now, this was borrowed by this esteemed tech company, but we added something of our own here. This is how they envision the development of OpenAI, AGI. They're not specifying whether it's practical. This is how they envision the evolution in time. The first level is everything related to perception and generation. Seemingly modern architectures of models, transformers, diffusion transformers are performing pretty well with perception and generation. There are some nuances, of course. The second level is reasoning. Reasoning not just similar to a human, but also explaining why you are getting to a certain inference. For example, in medical AI, it's important to get an accurate response, or when a doctor makes a decision, we also need to be able to explain how they came to the decision. Did they need to call a medical board to make this decision or not? Third is action. First, there was this unofficial image of information on Bloomberg, and then Sam Altman commented on it as well. OpenAI said that we are between the second and third. So we are probing the agency topic, but we are still not finished with the reasoning stage. I'll get back to that in a minute. Experimentation stage, sooner or later. And we are seeing the first attempts at it, the first stabs at it. With research problems, with scientific discoveries, seems more serious as compared to the previous levels. And for the last level, evolution with self-reflection and self-improvement. To what extent will this AGI be able to evolve when there is no human involvement, no human supervision? We have created this structure to represent the different value streams because they are creating value not just for science, but also for applications. The first category is multimodality. I'm going to describe each component separately. The main idea is to create something that, as opposed to the solutions, other solutions in the market, would perform well in terms of computing resources with modalities of different inputs and outputs. I'll get back to that in a minute. Agency, the second category. We all want to we all want our AI to have some mandate, but at the same time we want to limit the potential risks of making an error.
And these errors might lead to some consequences. Recurrence and reasoning comes to that category as well. I'm going to talk about that in detail a bit later. Here we're not talking about the living creatures, robotic creatures with multiple hands and legs, or even two legs, that can do something in the physical world. Now, that's the embodiment, and the world model. And compute and data. Yes, these are the major investments. These are the parties that pay for that. Because we understand that compute and data processing is where the bulk of the investment goes. On the top section, these are the emergent capabilities. That's what we called it. So all the useful stuff that will be the result, but what will be the outcome is not known to anyone. This is why it's called emergent capabilities. Let's look at the middle and lower layer and talk about that. Now, everything that we see right now, different architectures of the models, know how to work with different types of modalities for the input, but the output is usually pretty much the same. It might be text, or image, or sound, but we do not see a video with sound that is delivered by one model. We're still having some manual labor here. Having several modalities, that's an even more complicated task. And we do not think what modality we're going to use when we communicate with each other as humans. We show, we talk. And this end goal is to achieve that in an efficient and cost-effective way and quick way, to go to the architectural stack of the models that would help us to operate the modalities. We're talking about the input and output. To bake in one architecture transformer models and other models. And those who was on the gallery with the forecasters, Madora, he likes to use the word powerful AI, not AGI. He says it happens when we leap forward to something completely new in terms of the architecture. And he says that these are not going to be transformers for sure. The next interesting topic is agency. We see the examples that are pretty simple. Anthropic AI, the name of the company, I just talked about his CEO, and Google Gemini AI. This is when an agent navigates you on the screen on your desktop, and if you give the permission to use your keyboard and your mouse, it can do something useful like book a flight ticket or a table at a restaurant. These examples have been with us for many years, but they are becoming a reality right now, thanks to the LLM models themselves, and it was possible to technically operationalize that. So you take a page of with text translated to the language understandable by model, and you get something useful. Yesterday, my colleague sent me a podcast where sci-fi blogger tests Call 1 Pro, and he asks to write scenarios, how to ask your boss for a raise. And then he asks to rank up and down turn side effects. And it says, well, you have a quarterly review, that's the best way to approach your boss about the raise, or you can meet him in the hall, or you can use HR. But the worst thing you can do is to meet the boss in the hall somewhere and to ask for a raise. That's the worst thing. And it analyzes the context properly. You know, so it says like, okay, I have a kid coming soon, and the model says, no, you shouldn't risk it. You have a kid soon, you need financial stability for now. So the tasks and problems are becoming more complicated, and the agency, it's like microservice architecture. The automation related to the software development will be related to the agents. We're starting that trend, really. So, in terms of what our research is doing, in terms of our research, we would like to have some quick wins, some low-hanging fruits, and come to this end goal, to make sure that the automation is based on them. Now, recurrence, it was asked, the GPT-4.0, the weakest one in terms of the reasoning, I think, to draw a horse riding an astronaut. So it kind of puts it here, but it looks like Lego. On the second slide, these are the different. This is something, and GPT-4.0, yeah, here it started to say that, yeah, this is the legs of the horse, and it doesn't really look like an astronaut here. And it says that, okay, this is an astronaut's helmet. As for the embodiment, you have this kind of, in your head, some humanoid dancing robots. First of all, it's hard to understand how to, what is the optimal form of that device, so that it is optimal in solving all the features, in performing all the tasks that people do, because, you know, depends on the task that this robot will have to perform. But anyway, embodiment is not only limited by the physical embodiment. We have more and more synthetic data, and more tasks can be resolved in virtual environments in terms of the training. I'm talking about driverless vehicles and driverless planes, for example. Anything that can overload our useful cognitive capabilities and can translate that to the real world. One consulting company last year published a report who is going to be automated lastly, and what will be the industry that will be automated, will be the last one to be automated. This is the construction, because the foreman and the construction worker, these are the people who are hard to be replaced, because it's very hard for AI to work on a construction site, basically. Another important component is the world models. Soared at the start of this year. Sora was a great model. Now we have a second Sora. I think it was published a day ago. This is the first Sora, the flagship video when a girl is walking in an urban environment. In a couple of months, Kandinsky video was published, and here we have a Sber cat walking through the through a city. Looks okay, but it doesn't really have the physics of the real world. We don't have shadows somewhere. Sometimes some of the objects are moving quicker than they should. Will we be able to make machines understand the physics of the world with just feeding it with images and videos? I don't know. Now, compute and data. There are many areas here, huge topic for discussion. How can you make a distributed learning in terms of in the situation when data cannot be collected in one basket, so to speak? You can use the kind of a scheme of the use the file sharing scheme. There was this software that helped you to pirate movies and music. DeepMind and Google published a report about that, an article about that, and they compare this method with a file sharing service. Obviously, there are some new compute devices. Distillation of the models themselves, that's understandable because many models cannot be put into the compute capacities. They need more. And the code optimization, because it's understood that apart from making a good model, you have to be able to install it in real life. And it seems that our HR analytics made a kind of a survey asking about the skills that became very relevant. ML engineers and ML and C+ developers in generative AI. The number of jobs soared because everyone started to implement Gen AI. Small video generated by Kandinsky video about space. I decided that it would be the right thing to do to discuss the practical AGI as part of a dialogue, and I would like to invite the rector of Innopolis University, the professor Alexander Gasnikov. Alexander, please, welcome on the stage again. Now, Alexander, we are the people, thinking about all this. We're the dreamers in a way, But you work in the fields with the real AI applications, Because we usually try to put some KPIs and all the other things. Any scientific, we try to make any scientific and this creative work to be useful in practice. How can you put these creative, difficult things in one framework? Do you need to do that, or people just need to search without any barriers? They just need to think outside of the box. These streams that we've talked about, what is your first response? I think I actually like that. That's useful for me. You responding as a rector or as a scientist? As a scientist. As a rector as well. I need that. Trying to force people work in these areas is not something that you should do, maybe, but it's useful because it's a bridge from the industry. Scientists have to look into that. This is the request from the industry, and that simplifies our life because we had to go to you with that and tell you, help us here. I remember in the beginning of 2000s, you were working with a company, and you had to go there to listen to the task that is absolutely non-scientific, and then you put that in the scientific framework. And you are now doing the this scientific work for us. It is very logical and it's very, insightful. Maybe it needs to be fine-tuned in a way, because, we're talking about some intersections. It's hard to divide something if it is connected, but I think it's pretty convenient. It's convenient for me, yes. So, and I think that Innopolis is going to integrate into that system, into that framework. I think it's really convenient. Yeah, this is what we are going to announce, because we want to build our work, internal work, and the work with our partners to have proper partnerships, We're talking about the structure of the research vectors, research vectors. There's such a term in science. Anyway, these are the research vectors, so to speak. But if you look at this concept, like, what do you think about AGI? How did you vote? I forgot my phone at home. Oh, that's funny. Yeah, but anyway, I think that's an interesting question, And the presentation that I had today, I said that you have to learn evolutionary biology at schools. You would say, that's weird. How is it connected to AI? That's a good question, because if you understand how our brain works, it can help us to try and understand the development of AI. I think there was an experiment made with mice. There was an embryo of a mouse. They removed a part of the brain that was responsible for, let's say, vision. And they left the part responsible for the hearing. And they put the neurons responsible for the vision. They connected it to the part of the brain that was responsible for the hearing, and the mouse was using the parts of the neurons responsible for the hearing for vision. I mean, maybe it was different. I don't know, but anyway. It seems that this is a positive thing, that yes, there is a chance that there is an opportunity to have some general principles to do something multimodal, to find some common embeddings. That's good news, It's kind of evolutionary biology inspired idea. And for example, I want to jump higher because I want to play volleyball. I do leg work, leg days to jump higher, and then I start to want to run faster. But you can't do both. If you can jump higher, it does not mean that you can run faster. I mean, obviously the brain works differently, but the idea is super simple. Specialization is not for free. If we want to have strong agents and strong assistants, invest in everything in one thing is, I think, a non-obvious idea, because you see that among the kids, because when you see the phenotypical development among the kids, they like some things better than the other. And if you try to force kids to do something differently, to study something differently, it won't work, because they are wired for different things. They can do it, but they won't be great. So creating something of value, it would be, very hard to do. It's like if you take a person, you won't be able to make a champion in swimming, running, and all the other types of sports, I think the same will happen with the specialization. So we will hope that it will be all kind of gathered together and it will reach some level, but there will be some divergence as we talk about the AGI. A strong AI, meaning AGI, I don't know. Maybe there will be some PR campaign that would say, okay, we have achieved AGI. I think it will happen in a couple of years. There will be some good PR event for that. As for the, content, we're talking about some nearest ChatGPT style revolution, but in robotics, when we will have our own ChatGPT, not in the robots that look like humans, but like in robotics, because, a plane does not fly and like a bird, right? So there will be some things that we will take and copy from animals, but some mechanisms would be used. And in schools and in education system, we have to include the lessons of how we became humans, what experiments were done, with animals that show how the brain of this or that animal works. And if we monitor that, we'll be able to understand what is our future and how to move to that future. That's a great selection for ourselves, using ourselves and animals to understand how it was developing from an evolutionary point of view. And if you know the history, it's easier to forecast.
Well, once again, I'm spending so much time talking about the thing that is truly important to me. Not many people say it, so I'm taking advantage of your platform, sorry, to once again talk about it. No, it's okay. Indeed, in marketing science and its applied use is not about terminology. OpenAI, I think, started to introduce this term AGI, and they probably feel that the main capitalization in AGI is going to be in AGI, but the Gartner hype cycle also shows that we still need to wait, say, 10 years to the AGI peak. I would say that's pessimistic. But maybe they will be calling it ISI or powerful AI. It's not about terminology, but you started talking about mice, and rightly so. Even a mouse with a dissected brain can listen. Not all people can listen. I have a lot of people I know who have a perfectly fine and working brain, but they can't really listen. By the way, speaking of mice, that probably goes here in this group because it's about attention. A human being has this neuroplasticity, and neural networks also has it, but imported from outside. As for people, we are born with it. But I'd like to get back to the first point. What is the scenario that you envision for it? Some said that maybe AGI already happened. Maybe we already have AGI. If 1 in 4 are using Gen AI, and then there are companies and corporate surveys that say that in the next 5 years, 100% of information flows will be processed with the help of AI, meaning models that work with text, agent-based models. So given that, maybe we already have AGI. Can we say so? Or will we as human beings be enslaved by AGI? How do you see it? It's a difficult question of whether we have it or not. I don't think we have it. I don't think we achieved it. To do all of those things mentioned on the slide, we need a lot of resources. And in terms of accessibility of these resources, I mean to be able to train the model, the AGI model, instead of just doing inferences. Not many entities, not many parties have access to the sufficient resources for it. And then inference also requires resources.
гигачат бесплатно.
Not everything is publicly available. Well, GigaChat is. Yes, GigaChat is. Great job. My point is that the main problem we are facing is that the current phonemic architectures, I think that goes to point 6, item 6, from the perspective of density, we can improve the processing units, but up to a point. So maybe in the next few years, what we will be facing is this problem whereby the brain is millionfold more complex and fast in terms of the number of computes that it can perform in a second, and also the amount of electricity that is required for all these computes, for all these architectures. If we want to make progress, we will need to source this energy somewhere. That doesn't sound like such a trivial challenge. And also this simultaneity of inference and training. Instead of first training and then getting the inference, we could make these tracks parallel and simultaneous. I'm not a specialist in this, but what I've gathered from my communication with colleagues is that with AGI, we are usually talking about some cases, limited cases. There is a case where the model works and it helps you out, and it does have a certain wow effect, but is it worth it? It often is, but still we keep asking. So I don't think it's AGI yet. It's not something that works across all domains and is accessible to anyone. But I hope and I think that in a few years, all these questions will be resolved. I'm just judging by the trends, the current trends, because just a few years ago, nobody knew about it. ChatGPT, agent-based systems. The good news is that while I do optimization, and from the universality point of view, as any human being, I think, I believe that the more universal, the worse, because when something is universal, it means that when I ask it to perform a specific task, it will perform worse. But there are methods. Yuri Nesterov has been working on them for 30 years. They show that thanks to adaptation, this idea of self-fine-tuning, I saw it somewhere on your slides. Yes, we had it in an earlier slide. So I think there is an option of self-fine-tuning which would allow universality to some extent in specific domains. We are seeing it already in some AI-related domains, that something universal becomes state-of-the-art, competing with narrowly specialized methods, which was a bit surprising to me. But it is partially due to the fact that there is this fine-tuning to solve a task as you are solving it, trying to figure out what you are actually working on the go. It is about improvement of performance as you are performing a task, and maybe we could adopt this method, but you may say those are my fantasies because I'm not a specialist, but that's my take. Sorry, I'm being reminded of the timing. Unfortunately, I've been told that we do have a minute for one question, a very quick one, to Alexander, because you can catch me in these bare halls every day, but Alexander doesn't visit us that often. Anyone want to ask a question? Well, probably you're not interested in practical AGI, so there are no questions. What? Somebody's showing me something? They asked me at the entrance to the hall, do you want someone to ask you a question? I said no, but I would welcome a question to Alexander. Oh, there's one. Hello, Sasha. Maxim, thank you for the lecture. I really hoped to run into you later to ask my questions, but since I have this opportunity, what are the cases where universal was better than narrowly specialized? Because we are currently working on something very similar, and we are at a junction. Do we use universal tools, or do we spend more time and more resources but create a narrowly specialized tool? Well, my answer will be this. Let's say you are training GigaChat. GigaChat is a function with inferences based on labeled data. We optimize the weights of the neural network with an algorithm so that the mismatch is lower. And then the question is about the learning rate with our training method. What is the method step? Usually it is related to the parameters of the problem smoothness. The universality is that there may be some universally working general recipes, recommendations, whether you're training GigaChat or something else, recommendations as to how to perceive information and set the learning rate.
Вот специфику этой задачи учесть, а можно общий рецепт
You
применить.
can try to factor in the specifics of a particular task, or you can generalize it. Adam, by the way, it's not yet universal. They are
То есть,
shifting towards universal, generalized recipes, and they are performing rather well. So the attempt to
уместные какие-то общие
create a
рецепты,
narrowly specialized tool is not always successful.
идею, физику, что вот так надо отслеживать гладкость, и это будет неплохо.
Because there may be some generally applicable recommendations. You set this smoothness and then it works well.
Насколько я знаю, вот
With the training of GigaChat, as far as I know, they used things that can be called universal, I think, partially.
обучают много чего еще.
The same stuff is used to train a lot of other things, and those are general principles. So this is, once again, universality, but you can go beyond those limitations, those borders. Of course, you can broaden this context. Once again, it also applies to convolutional neural networks. There may be some universal logic that you can use, and then you assess the scale of its universality. It's a very interesting research problem. So this is a great idea, but how great is it? This is a universal thing, it's very good, you need to put it in the textbook, and this, some time will pass and it will replace adversarial networks, diffusion networks. But if something looks like it's here to stay, then we need to promote it and advertise it. Thank you very much. See you next year.
большое. Саша, спасибо за участие, за твое...
Thank you, Alexander, for joining us, and thank you for your enthusiasm. Alexander Gasnikov and Maxim Yuromenko